All right, so we were going to start learning about 4.2, which is shifting and stretching. You already know about shifting and stretching because we've done this with our other functions in the past, and you've already understood the pattern that goes. So being a mathematician, one of the things that you should do, and this is not a mathematician, this is more like a human, like one of the things that you should definitely be comfortable with is learning something and then learning something new and then saying like, hey, I wonder if it applies to this, right? So you already know about shifting and stretching because we did it with, we saw it with quadratics, we saw it with just a couple of other different functions. I don't know why it escapes me right now. So we're now wondering, does shifting and stretching work the same in our rational function? Okay, so our reminder is this graph each function. You guys all did this. I saw some of your work already and you understood. Really quickly, remind me, what does this -3 do? What does this -3 do to your function, right? Yeah, it moves it along the x. Very good. Some people say it moves 3 to the right. Exactly. It doesn't move it left. Tell me why it doesn't move it left. Yeah, it lives in opposite land. Very good. Very, very good. Yeah. You guys, okay. All of you got that. Perfect. So number one, it's moving to the right, but what is the shape of it? I said it is moving to the right. What is its shape? What is the name of this shape? Yeah, it's a quadratic. Some people call it a parabola. Quadratic is actually the name of the equation, the type of equation. Parabola is the shape. Does that make sense? So this shape here is going to move, you guys said 3 to the right. So I imagine that it was on a clear piece of paper. I'd go 1, 2, 3, right? So instead of this point being here at 0, oh, that was horrible, but here at 0, 0, the vertex being at 0, 0, and we moved it over to the right 3. So now it's 3, 0. What does this number do to it? What does that half do to it? Yeah. So it's a the technical term is it's the A term, and A is in charge of making him skinny or fat. And you guys are like, Ms. Johnson, don't call them that. Parabolas, they don't have feelings. They're okay. So if this number was larger than 1, it would make it faster, right? But make it faster. So if this is what my normal parabola looks like, I can actually just graph them because then that would be easier. So x squared looks like this, right? But say 2x squared, he looks like this. He's skinnier. See, the blue guy is skinnier. It's okay. Again, he doesn't have feelings. Don't even worry about it. So here, if I look at 1/2 x squared, right? See the green guy, he's bigger, he's fatter. It's okay. That's good, right? So it in my mind, it makes him slower, right? Slower. What does that mean, Ms. Johnson? So if he goes up, he's going up at a slower pace, or he's less than. I also think about him as not as fast as his original parent function, right? So let's see if you guys are right. I'm going to squeeze in my little x and then -3 here, parentheses. Is that what you imagine? Move him over 3 times and make him a little bit wider. And so you guys all said, yeah, that's what I imagined. So what I'm training you to do is, even though you have access to a graphing calculator all the time, your brain should be able to imagine what each of these numbers do in order to give me a pretty accurate picture. Right? Okay. Let's see what happened right now. Something happened. Okay, second. This one, you guys should all be able to tell me, okay, Ms. Johnson, this does this, this does this, and this does this, right? So let's see, what does the negative do? What does this negative out here do? Yeah, it flipped them. Very good. Flipped them. What about this +2? What did he do? Yeah, he moves left too. Very good. Very good. And then what about this -1? What does it do? It's down 1. Very good. So you can imagine that this guy, I don't know, I think about it in steps, if that makes sense. He got flipped upside down. We move him right 2, boom, boom. Oh, sorry, left 2, my bad. Boom, boom. And then down 1, boom. So here's my guy. He moved left 2, boom, boom, down 1, boom. So this is where my vertex is, right there. It's not going to draw it. I don't know why. There it is. And then my parabola goes upside down. It's a cubic. I didn't even pay attention. Jeez, Miss Johnson. Thanks for having my back. It is a cubic. So then it doesn't look like this at all, does it? It looks like this. And then we flip them upside down, so he looks like this. So imagine this guy through that point. So Miss Johnson's going to try to draw here. Thanks for having my back. Miss Johnson makes mistakes. Yep, she does. As long as you check your answer. So you would plug this into your calculator, boom, it's correct, right? So we learned that vertical stretches and shifts work in parabola land, in cubic land, but did it work in log land? And everyone's like, yes, Miss Johnson, it worked in log land. That 2 is just your base, and it moved right 1. That's all it did. So today, you should be able to transform the graph. Transform means you're shifting, you're reflecting, you're stretching. Okay. And another word for shift is translate. Translate. Move left and right, up and down. That's translating. Okay. You should be able to write the equation from a graph. So can you go backwards? Very classic in math is this. I give you the equation, you give me the graph. And then now go backwards. If I give you the graph, can you now give me the equation? And the answer should be yes, Miss Johnson. Yes, right? Okay. So let's see. Predict the horizontal and vertical asymptotes of a function from the equation. So that's very interesting. Okay, that's what I really want you to focus on, is if you know where the horizontal asymptotes are, you can pretty much graph your branches. Okay, you can graph those 2 little whoops and, you know. So what other functions can be made from 1 over x, and what were the graphs looks like? All right, so here goes. In the previous lesson, you were introduced to the function 1 over x. Before exploring the family of related functions, let's clarify some features. And we did that with our last thing, right? We know where the asymptotes are. We know where all these things are. So you should know that the horizontal asymptotes, you should have said it is y equals to 0. Oh, wait, I will tell you. Let's see. Let us look at people's. I'm going to pick someone random. Yeah, y equals to 0. Exactly. Vertical asymptote, x equals 0. Boom. If you need answers, write it down. Okay. Anchor points. So Ms. Johnson, what are anchor points? It's just points that you can plug in to know where your branches are. So if you guess that your horizontal asymptote is this, but it's wrong, your anchor points will tell you that. Okay. Your anchor points will tell you that. So really this person is just plugging in. If I plug in 1, I get out 1. If I plug in -1, I get out -1, right? And then they just started graphing these little branches. Okay. Okay, let's move on. Where am I? 8. So not there. Sorry, my bad. Okay, so now you're ready to use this information to figure out the graph of f of x 1 over x can be transformed, meaning I can shift it left and right. Another word for shift is translate. I can reflect it. I can stretch it. I can do all those things. Yes. Okay. As you answer the problems that follow, look for patterns that you can generalize to describe the transformation. The biggest questions that you should have is, does X still live in backwards land? Does Y not live in backwards land? If I see numbers, will I do the same things that I think I should be doing to them? So let's just try. It says in each of the following problems, you're given either a graph or a description of a function that is a transformation of f of x equals to 1 over x. Use your amazing math skills. You all do have amazing math skills. Some of you are like, shut up, Miss Johnson, I don't have amazing math skills. Okay, fine. You don't. Let it be as you have said. To find an equation for each. Okay, so this is a really tiny graph, right? They're kind of showing us some stuff here. What do you notice? Anybody notice anything here? What's the biggest thing that you notice? Yeah, it moved up 5. Very good. Okay, so I wonder, okay, so if it went up 5, how does that affect this function? Where does up 5 go? With x or after the function? Yeah, it goes right here. According to you all, this is what you think it is, okay? And then you check, right? Like this is the power of the calculator, right? Plus 5, but we already saw that. Ms. Johnson, you just showed us this. I know, right? So are you like convinced that it should be +5 here and not, I'm not going to write it all out because, and not +5 down here? Are you convinced of that? Do you absolutely understand why it's not 5 here? If so, then you're good. You are good. You understand it. You get it. If you're a little bit like, I'm not so sure, put a 5 in. Oh, because it's affecting the X, right? So that's the way your brain should be like talking to itself, should go like this. The reason why this 5, I'm going to turn this guy off. The reason why red 5 moved it up is because it's after the function. The reason why blue 5 moved left is because it was with X backwards land, right? Very good. All right, number 10. So wait. Okay, so here the directions are, you are given the graph of the description of function. Oh, figure out the transformation. Okay, here. So here is a function. Is this how it normally looks? Is this how it normally looks? No, right? It got like moved. Yeah. Normally it lives here and here. This is my horrible drawings. But it got moved. It got moved to here and here. I wonder what, like how does that show up here in my equation? It has a negative. Where? In front. Okay, someone says here. And then I say, I don't know. I don't necessarily believe you. You don't have to believe me, Miss Johnson. Just oh, look at that. Okay. Then the next thing that you should be doing, and I didn't do it over here, is you should be checking your anchor points to see if there's any like stretching or anything like that. Does that make sense? If there's any stretching, I want to make sure that that's there. So here, I know there's no stretching. If you guys have better eyes than I do, right? So if you look here, when I plug in 6, when I plug in 1, I get 6, right? So when I plug in 1, oh yeah, I got 6. So that's good. Okay, so same thing goes here. When I plug in 1, I got -1. So when I plug in 1 here, did I get, I did get -1. Okay, I think I left this here by accident, so just ignore this. This is me like copying and pasting, so I apologize. Here it says the function has a vertical asymptote of x equals -3. Wait a second, Miss Johnson. It has a vertical asymptote of -3. I wonder where that shows up in my function. Okay, so my base function is going to be 1 over x, right? How do I get a vertical asymptote? So right here, my vertical asymptote's right here at x is equal to 0. How do I get it to be -3? Okay, I'll show you. How do I get my vertical asymptote over here? I want it to be here. So are you moving down 3 like this? -3 like this? Oh, no, that didn't work. Oh, someone said put it with the x. Okay. Like this, -3 like this? Oh, put plus. Oh, because x is backwards lands. Very good. So you guys all got it. Yes, I play the I don't get it, Miss Johnson. So that everybody can see what's going on. Okay. So yeah, so I got that part. Check. So this part is done. Right? You all see me how I said x is equal to -3. Now I'm going to go to my next clue. My next clue says horizontal asymptote at y equals to 0. Is my horizontal asymptote at 0? And you guys are like, yeah. Because look, Miss Johnson, you didn't move it up or down. Everybody okay with that? Then it says contains the point -2, 1. So -2, 1, 2, 1. Oh, okay. So when I plug in -2, so these are those anchor points. When I plug in -2 to my function, and so this function is wrong right now. Let me fix it. Oops, no, that's not where I want it. Right here. When I plug in -2, I should get out 1. So when I plug in -2, -2 plus 3 is 1. 1 divided by 1 is 1. Yay. Check. Oops, I forgot to check this. Check. When I plug in -4, I should get out -1. Okay, -4 plus 3 is -1. 1 divided by -1 is -1. Yeah. So I have 1, 2, 3, 4 clues. Oh, I hope this is okay. If I plug in 0, I'm hoping that I get out 1/3. So on my function here, yeah, that looks like a third-ish. But when I actually plug it in, right? When I say plug in, I literally mean this. I'm plugging this guy in. I'm going 1 divided by 0 plus 3. And does that equal to 1/3? That's the question that they're asking you here. Is that true? When I plug in 0, do I get out 1/3? Everyone's like, yes, Miss Johnson, perfect. Okay, so here's what I need you to do. There's only a couple more slides that I want you to try out on your own. This is where we're gonna pick up on Friday. So, but I want you to try these on your own, okay? Go through here and be like, oh no, they just gave me a graph. So you have to take your very observant eyes, your skills of observing, right? And say, what did they actually give me? Did they give me enough information? And the answer is yeah. So look at this and you're like, everyone feel confident on finishing this one? I'm getting yeses in the chat. Yes, yes. Thank you. This one's another one of those clues. They gave me clue by clue by clue, right? So here they gave me my asymptotes and then they gave me a bunch of points. My suggestion, graph these points, right? Graph them, right? Look at what they gave you. Here, did they give you enough information? You guys are like, oh, I see what they gave me, right? Don't tell your neighbors right now. Let them, they have to learn on their own. What about this one? Did they give you enough information? Answer is yes. The answer is yes. Okay, this last slide right here. Here they're gonna, what you're gonna do is, here's your directions. Match each equation to the phrase that describes the transformation. So you're gonna play with these. So this is where we're gonna pick up on Friday. Okay, we're gonna pick this up on Friday. All right.